Hello, a very good morning to all of you. Welcome to ARCHIDEX Fast Forward webinar series, jointly organized by the Malaysia Institute of Architect (PAM) and as well as the CIS network. My name is Architect Alice Leong. I'm a practicing architect and interior designer. Currently, is actually the PAM honorary treasurer. So I'm also sitting in the SDG commissions in the International Unions of Architects as well as member committees of the Acacia Green and Sustainable Architecture Committee. So it is my honor to be our moderators today. And today's sessions, the topics will relate to the energy save versus the energy waste. So this will be presented by our very knowledgeable skills or engineers, Engineer Jack. But before that, I would like to also thank you for spending your precious time, the morning time with us today. And bear in mind, actually, these sessions also is collaborate together with the Electricals and Electronics Associations of Malaysia. In short form, we call it TEAMS. And it is a representative bodies of the electricals and electronics industry in Malaysia. So TEAM was established in 1952 and aimed to work closely with all the government departments, statutory bodies, as well as the private sectors to ensure and to promote all the growth in developments of the electrical and electronic industry. So TEAM is also a member of Asian Federals of Electrical Engineers, Contracts, and as well as the Borrow Spectrums is affiliated with the Federals of Asian Pacific Electrical Contractors Associations. All right, maybe for ladies and gentlemen, the Architects Fast Forward is actually a webinar series. It's a focus on the holistic perspectives from all the industry, especially in our constructions industry. So each session we will bring to you together collaborations with other industries, renowned architects and other constructions industry professionals like engineers, the interior designs, and so on and so forth, to share their experiences as well from various capacities as well as their own perspective, their ideas and their view. So this is actually to help our industry to foresee and forecast the businesses as well as the education to address the current main issues and the challenges that we face, especially in this pandemic situations. So before that, I would like to remind our audience two very important things that before we start our session. So is to take note that this session is actually CPD applicable. And to claim your CPD point, please follow the instructions shown at the chat box or the sections at the right of your screen. And also, we truly appreciate you could do a very quick and short survey through the link, which is now you can be seen at the chat box that I mentioned just now, but you can do it after the talk. So your feedbacks and your ideas and the thought is very important to us that we can improve from there and we can create a better platforms to everyone. So without further ado, allow me to have a very short introductions for today's speakers, Engineer Jack Chang. So Engineer Jack he's my friend, and we've been knowing for a few years through the platform of Sustainable and other industries. Okay, so Engineer Jack is active involved in mechanical and electrical building services engineer for the past 28 years. So he graduated from the National University of Singapore with bachelor degree in engineering mechanicals and was involved in consultancy, contracting and marketing of technical products since then. Currently, he is actively involved in providing the enhanced commissioning services for projects seeking certifications on LEED, GBIs, and mechanical services inspectors for residential and commercial building. So he is also involved in energy audits for existing commercial building, seeking green building certifications. So besides this, he was a member of Malaysia Standard Committees of Chiller Performance Efficiency and the MS 1525 Energy Standards. So without further ado, let's just welcome Engineer Jack here. Engineer Jack, could you, yes.
Yeah, thank you, Alice.
Thank
you so much for the introduction. Yeah, good morning, everyone. This is one of the few rare times I'm speaking to a computer. because normally I would speak in front of a large audience, or not large audience, in front of an audience. So everything we have to try for first time. So this is probably one of the first few time I'm speaking right through my PC. Okay, so this is also a very rare instance for you all, because this may be the first time also you have a mechanical engineer speaking on an electrical engineering platform. So how is that? I got to try to change my mechanical thinking to more electrical like, and I'm so to understand that most of you all are architects and trade, probably some are engineers, and some are probably suppliers, manufacturers. So I'm making this presentation as lay as possible. So I'm taking out all the technical details, I'm taking out all the calculations, and I'm putting in lots of pictures and photos just to please Alice, okay, or rather, just to make it more definable for the architects. Okay, so I'm wondering, okay, for a very long time, how am I going to introduce, or rather, how am I going to explain energy savings to someone that's not in this line? Okay, just imagine that if you take your energy as a currency. Okay, just imagine that you take energy as ringgit. Okay, suppose that every kilowatt you spend is equivalent to every ringgit you spend. So if you take it that way, then it would be much easier. Then we can have lessons on how you save your money and how you waste your money, and we can equal that to how you save your energy and how you waste your energy. Okay, so suppose we take it as currency. Okay, the first lesson that we have to learn is that we have to know how much money we have, right? So in order to do that, we have to do an accounting. So we have to do a baseline accounting. If you don't know how much you have, you won't know where you are. You must know where you are standing. You must know your baseline. So in energy, we call that energy auditing, right? We have to measure our baseline. It's like knowing where you are, how much money you have in the bank, how much money you have in your investment, how much money you have in probably your other assets. Then we have to do equivalent procedure for your energy. So we have to audit the energy. So in order to audit the energy, we have to, normally the first step is to measure whatever we have. Okay, just like engaging an accountant, you need to hire engineers to do auditing. Okay, you have to put in your equipment to various parts of the building, and you measure it. Okay, and measurement can sometimes take a few weeks, sometimes take a few days, sometimes takes a few hours, or sometimes can even take years. So the longer the measurement, the more accurate you have, the more accurate data you have. The same as the how you account for your money. If you account your money for longer term, then you have more data, and then you will have more accurate indication on how you spend it. Okay, so I'm going to show you something here. Okay, this is one of the first thing that we have to do. Okay, in order for you to save your energy, or in order for you to know how much you're spending, you have to audit your facilities, your building, or your factory, or your house, or whatever. Even you have a own condo unit, you can actually audit it. So all this data that I'm showing you are actually real data. Okay, and these are the data that we have done, we have audited. Okay, we can get this data because we ourselves are building commissioners. So we actually commission the building, we actually commission the energy part of the building, and we get real data for you to share with you here. So if you look at this building, okay, this is actually an office in Kuala Lumpur. I've decided to take out all the name for copyright sake. Okay, so I'm not going to put the name of the building, but rather I'm going to put some generic names, like example Office A, probably Office B, Shopping Mall A, Shopping Mall B. So without naming the shopping mall or the office itself. Okay, so if you look at here, you find that the major consumption, as predicted by many people, is your air conditioning. Okay, I put here HVAC. HVAC is actually a generic term for heating, ventilating, and air conditioning. Also equivalent to your air conditioning load. So you look at the chiller plant and your ASU. I'm not sure whether you can see my cursor here. These two sections here, it actually consists about 32% of your whole facility consumption. But if you look at it properly, this 32% is not the largest. Okay, the largest is still your tenant. Okay, the tenant actually consumes 41%. In most buildings, it consumes about 41 to 45, depending on the type of mix you have. And if you have a tenant that actually operate for 24 hours, probably you get a slightly higher consumption. But the problem with this is that normally we can do a lot of things on the chiller plant because it's actually owned by the building owner, but hardly you can do anything on the tenant. Okay, so this is one of the buildings in Selangor, and another building which I'm going to share to you also. Okay, another office in Selangor. Again, you see the same thing. Aircon consumes 37.5%. Okay, in fact, when you hear people telling you that air conditioning is the highest consumption, is actually true. Okay, most of the time when we audit buildings, we find that the air conditioning energy consumes the most for many. I mean, for every instances. Actually, we can say that for most of the instances, the air conditioning consumption would be the highest. And you can see that the other one is the common area. Okay, common area and lighting. These two also consumes a lot. Okay, so this common area, I would like to clarify, it actually consists of both lighting and small power. So because during the logging, we didn't actually separate it out, so we combine it, and the lighting is actually a tenant lighting. So again, you look from here, it's actually air conditioning is the highest load again. And even if you take an example of a shopping mall in Selangor, okay, this was taken in 2012, but it's still applicable nowadays. Okay, you find that the largest consumption, okay, is also aircon, 47.12%, and the tenant is about 43%. Okay, this mall is actually tenanted to different lots. Okay, meaning that the owner actually rent out all the lots to individual tenants. Okay, so the individual tenants come in, you have F&B, you will have boutiques, you have cinemas and whatever, whatnot, or all the other retailers will come in, and their consumption is actually locked in this total tenant consumption pie chart. So again, HVAC consumes the most. So let's see another last one. We see the last shopping mall in KL. Okay, this is in 2017. So the same story applies. So what this tells us is that air conditioning is actually one of the major energy consumer in a building. Okay, and let's say that if you are an architect, or let's say that if you're an engineer, okay, it would be good to design the building that consume less air conditioning power. So one of the way to do it is actually either you do architecturally have more naturally ventilated space, or you reduce the amount of air conditioning usage in the area at all. But from this energy law, you will also realize one thing. Okay, you realize that if the more divisions are being made, right, if the more sectorials are being measured, then you will have a more detailed you have a more detailed consumption for individual sectors. For example, like, okay, in this shopping mall here, we actually instead of logging in the whole plant room, we actually log the ASU separately, we log the chiller equipment separately, we log the condenser pump, the chill water pump separately. So the more individual loggings, the more individual sectors that's being logged, you will have a more accurate data. But of course, if you log more, then it'll be more expensive and you'll be even more troublesome. But bear in mind, in all these samples, you'll find that the air conditioning is the highest consumer. Okay, so that's lesson one. Okay, sorry. Yeah, another thing. Sorry. another thing on lesson 1 is that when we lock the whole consumption, okay, we even lock the incoming. Okay, another good example is to get your daily profile of your operation. So this is an office in KL. So again, we log the daily profile, and from the daily profile, you'll be able to know where your various load are. Okay, so if you find that you will have a constant load, you will realize that no matter wherever whichever hour you are, whether in the morning or in the afternoon or in the evening, there'll be a constant load, which we call the base load. Okay, so for example, in this building, the base load is about 300 kilowatt. Okay, so no matter at which time of the day, okay, this base load will always be there. Meaning that this base load is actually a load for the fundamental to the building, and it will require for it to operate even though there's no occupancy. Okay, so so this is what we call a base load. And if you look at the profile log again, right, you will find that there is a peak load. Okay, the peak load happens momentarily, meaning that it will happen for probably about maybe 10 minutes. Sometimes it happens about 20 minutes. Sometimes it can be as long as half an hour, but it never stays there. Okay, it will go to the peak and then it will drop again. Okay, and the most important load that the building will consume is the average load. This is the load that occur during the occupancy of the building. Okay, it will happen probably at about 8 o'clock. Like for example, in this profile, it happened from 8 o'clock all the way down to about about 1800 hours a night. Okay, so this is the average load, and this load is the one that's the building consume. Is where the building is actually consuming. Okay, so when you log, okay, you will find these three important parameters, and it's very important for you to reduce, okay, to reduce all this load. Okay, so these are lesson 1. Lesson 1, you must know where you are. So once you know where you are, you have all the profile, you have the baseline, then only you can go to different other steps. Okay, so another way to make the money, to invest the money is to make it grow. Okay, so the lesson 1 is to know where you are. Lesson 2 is that with money you have to make it grow. Okay, so same with energy. Okay, energy, we can't make our energy grow, but what we can do is that we can harness renewable sources. Okay, also one of the sources that we can harness is actually solar power. Okay, solar PV panel, and solar PV panel is free. You can get it from the daylight. So all you need to do is just install some PV panels, and these PV panels will attract light, and the light will be converted into electricity. It's simple as that. Okay, so this is a shopping mall. The photo you see here is a shopping mall in KL, and they have actually installed about 1,000 kilowatt peak. Okay, 1,000 kilowatt worth of solar panel in the roof. So because we are building commissioners, so we would like to see the actual savings from this solar panel. So what we did was we actually locked the system. Okay, we locked the system, and here is a graph. Okay, you may find this graph a bit peculiar. Okay, this is a graph of power generation against time, meaning that at various time, the amount of power is, how much power is being generated over a period of time. This is over a period of about a month, and the logging are being done at once every 15 minutes. So you will see here. Okay, you will see here that there is one line here. Okay, one line here, go all the way to the peak and come down again. Okay, I want you to concentrate on this line first. Okay, when the sun begins to shine at about 7 o'clock, you will see that the solar panel begin to generate electricity. Okay, as it goes to the midday, as the suns become brighter and more intense, the generation become higher. Okay, higher and higher until about noon. you have the maximum generation, and then in the evening it will drops again. Okay, it will drops again. So it follows a profile. It follows a profile. Okay, but you realize that it doesn't really follow this profile every day. Okay, someday it will be lower. Okay, someday it will be less. Okay, someday it will be even very low depending on the weather condition. Okay, so if you look at this, okay, I've already put some I've overlaid certain curves on this solar power. You find that the highest generation is on this line. Okay, on this line, with the installation of 1000 kilowatt peak, you will get about 700 kilowatt at maximum. Okay, at daytime, and the lowest peak is probably about 300 kilowatt. Okay, this depending on the time of the day that you're measuring. Yeah, this was measured during the time it was measured in February, so you will see that the peak is actually higher. I will show you later some of other slides where if you measure at other time, then the minimum would be lower. Okay, so the area below the red curve is the energy that's being generated, and the area below the blue curve is is also the energy being generated for for days that are cloudy. So you find two curves. This is the maximum possible generation, and this is the minimum possible generation. Okay, so what does this tells us? Okay, this tells us that if we install a solar power energy, then we will expect some savings, but the savings may not be as listed in what the manufacturer said. Also depending on the condition of your ambient condition of your outdoor unit. Sorry, not condition of the condition of your outdoor condition. Okay, so in the next slide here, I would like to show you a log again. Okay, this the top curve here. You will see that this is the log of the actual consumption for this shopping mall. Okay, remember the log that I showed you earlier on, the profile that I showed you earlier on the office. You will probably get the same profile, but you realize that there is a dip here. Okay, there's a dip here. Okay, why is this so? This dip happens because the generation from the solar PV have reduced it. Okay, they have actually reduced the average load along here. If you remember the average load that I told you about, okay, so it reduces the average load, and it actually dips down and goes up again. Okay, remember that the area below this curve is the energy consumed. So with this dip, you find that the energy actually the energy consumed is actually much less than predicted. Okay, so from this measurement, we can actually predict, we can actually estimate how much money is saved just by using solar PV. Of course, it all depending on the building type, but for this sample, for this shopping mall, okay, when we did the calculation, right, okay, when we take the maximum possible saving, okay, this shopping mall can save about 61,000 per month, okay, maximum, based on the 30-day rationalization, okay, 61,000, and the minimum saving they can achieve is 21,000. So it's actually quite far, okay, between 20 to 60,000. But I would say that the savings would be averagely in between these two. Okay, so let's take a look at another example. Okay, let's take a look at the office in Selangor. Okay, this was taken in 2015. Okay, so in 2015, in May 2015, okay, the installed kilowatt peak is 32 kilowatt, but you can only get 20 kilowatt maximum. Okay, it's very hard to get the maximum kilowatt peak. Okay, whatever you install, you may not get exactly what you get for. Okay, and the minimum kilowatt peak is 19 kilowatt. Okay, so the area below here is 200 kilowatt hour. The area below here is 133. So the savings is in between it's in between 1.6 to 2.3 1,000 ringgit per month. Okay, and this was taken in May 2015. Okay, let's take another example. Okay, let's take another example. Okay, for this example, I can give you a better indication because we have logged in for longer period of time. Okay, so you probably will be able to see the differences between the hot months and the wet months. Okay, let's try this building. Okay, in 2019 October. Okay, October 2019 installation 71 kilowatt peak. Okay, you get 60 kilowatt max and 15 kilowatt minimum. So the savings is in between 1.2 to 7.7 thousand. Okay, let's take a look at it during November. Yeah, you find that during November, right, because there are many rainy days, your minimum generation is actually very low. Okay, minimum generation is actually about 8 kilowatt. Okay, for the whole day. So your minimum savings is 423. So you compare to the previous one, is 1,002. So 1,002 is sometime in October where the days are hotter, there are more sunlight hours, and you compare to November to December where it's actually more wet. Like the weather we're having now. I think this morning you woke up, it was raining. I don't know about your side, but my side here is raining heavily. So every night it was raining, and I have a very good night's sleep because it was cold. So probably I think it happened same all over Malaysia too. So so from here you will see that okay, it's good to invest in in a solar PV, but also you may not get the actual full savings. Okay, so you get savings, but depending on the time of the day or depending on the outdoor weather condition, whether it's hot or whether it is rainy, so your savings will be very, very different. Okay, so how do we reconcile all these measurement? Okay, you can actually forget about what I've told you earlier, but whenever you invest in a solar PV, just remember the annual yield. Okay, the annual yield normally is between 1,000 to 1,004 kilowatt hour per kilowatt peak. Okay, this annual yield is a ratio of between the amount of energy being generated divided by your installed capacity. Okay, meaning let's say example, if you install 100 kilowatt peak, okay, then probably you will get 1,000 times 100 kilowatt hour of energy over a period of a year. So your value would normally be between 1,000 to 1,004 for our local condition. Okay, so that's all for lesson 2. Okay, I'm going a bit fast. I hope you all are okay with the speed. I can't get feedback from you all, so I'm not sure whether I'm at the correct speed or not. But okay, let's move on. Okay. Yeah. Sorry. Before that, you have other renewable sources as well. Yeah, I forgot about this slide. Yeah, you can have hot water heater. Okay, some of us even put wind this wind turbine on the rooftop, but hardly in Malaysia because our wind generation is actually very low. And if you live nearby a river, okay, you can try to get this small propeller. Okay, small propeller turbine, small turbine propeller you put on the river, and the flow, the current will actually turn the turbine and generate electricity. Okay, this is only good for camping, maybe small houses where you need to only light up 1 or 2 bulbs. Okay, so okay, lesson 3. Okay, lesson 3 in finance. Okay, you rely on professional investor. So whenever you do investment, right, you will actually get a professional to do it for you. Okay, most of the time, for me personally, I have a unit trust, so I rely on my unit trust manager. I rely on them heavily. I rely on the mutual fund managers to manage my investment. But for energy, right, to maximize your return, okay, in order to maximize your return, the best thing is to buy the most efficient equipment you can afford. Okay, so this is another thing that's very important, but of course it is quite difficult to be done because when it comes to investment, meaning that a lot of capital outlay is required, and when capital outlay is required, then there are a lot of financial decisions to be made. Okay, so okay, remember initially I've told you that from the various data that we logged, we found that the aircon equipment consumes the most energy. Okay, so we will actually go into the area. Okay, whenever you buy purchase an air conditioning equipment, especially chillers or pumps or cooling towers, buy the most efficient you can afford. Okay, and how do we know whether the equipment is efficient? Okay, normally the manufacturer would declare the efficiency. Okay, they will declare the efficiency, and the chiller, a sample of the chiller will be brought to the factory to be tested. Okay, tested according to the X-ray, or rather according to few standard points where the chiller will operate, and these few standard points will be compared against the declared efficiency. Okay, so this normally is done, and I would suggest that every project to perform this test, because it's important. And once the test is passed, then we know that at least the chiller is operating at the rated efficiency. So get the best efficiency you can afford and get this efficiency tested. Okay, there's no point for you to get the most efficient chiller, but you don't test the chiller. The chiller itself may not be performing, even though it's being declared efficient by the manufacturer. So you have to test it. So you have to bring it to the factory to test. So once it's being tested, okay, you operate the chiller. Okay, we will have to do a site test. Okay, a site test is very important. So if you look at this graph here, okay, you will find that there's two distinct curves. Okay, two distinct curves. One is the green curve. The other one are the dots, no, the red dots. Okay, so the green curve is the one that's being is the efficiency that's being declared by the supplier. Okay, so this is being rated in kilowatt per ton. So the lower the values, the more efficient it is. Okay, so in other words, if the points are lower, then it's more efficient. If the points are higher, then it's less efficient. So because you consume lower energy compared to your electrical system. Okay, so bear in mind when we talk about kilowatt per ton, the lower the kilowatt per ton, the better. So okay, just now we have tested the chiller at the factory. So when you do an actual site test, the site test must at least mirror what is being declared by the manufacturer. Okay, so everything must be mirrored. Okay, so example, over here is low, yes, it's low. Over here is high, yes, it's high. Okay, so it must mirror. Okay, then the other thing that you have to find out is that what is the deviation from the actual test to the manufacturer declared efficiency. So if let's say if you find that all these values are much higher, then you can ask the manufacturer to come and probably either to reassemble the chiller again, or in worst case to replace the whole chiller until you get the efficiency that you require. You find from this curve, right, that it will never actually match. Yeah, it will never actually match, because sometimes the running condition are actually different from the tested condition. Okay, the test condition may be slightly different from the operating condition, especially your condenser entering temperature. Your cooling tower temperature may be higher than the one that's being used for testing in the factory. Okay, but by anyway, this actually is quite good. Okay, because it actually mirrors, and the difference is actually not very large. Okay, so this is actually a centrifugal chiller. So you find that different chiller behave. Okay, so if you look at a magnetic bearing chiller, you find that you realize that the manufacturer actually declare efficiency almost uh, uh, dropping as it goes to low loads. Okay, meaning that at low loads its efficiency is better than high loads. Okay, but when we run the system, we find that yes, it's a bit true. Okay, we find that the efficiency actually is actually straight. No, it doesn't really suddenly goes up at the end. Uh, but of course, it also doesn't really fall exactly on the spot. So again, the site condition is different. As owner, you have to make the site condition like example like the chiller. Okay, you have to clean it because once the chiller operates for a while, there will be the coil will get dirty. The approach temperature will increase, meaning the temperature of the refrigerant against the temperature of the chill water will increase. The fouling will happen, the tubes will get dirty, and you wouldn't get the efficiency anymore. Okay, but very important is to compare these two. Okay, once you compare these two, we found something. See, the red one are the centrifugal chillers, and the blue ones are the magnetic bearing. The magnetic bearing chillers efficiency is almost constant all the while. It is most constant, but the centrifugal chiller efficiency actually drops when it goes to very low loads. So again, it's up to the owner. Okay, if your building is always operating at full load, if a chiller always operating at full load, the building always occupied, then doesn't really matter if you go for magnetic bearing or centrifugal chiller. But if a building is actually going towards the lower end load, right? I mean, if you can't occupy your building that much, then it's better to go for a magnetic bearing chiller. Okay, so that's all. You get the most efficient chiller you can afford. Okay, let me check my timer. Oh, I'm really running out. Okay, so okay, I'm going up. I try to go a bit faster now. So okay, another lesson is that okay, don't spend unnecessarily. Okay, reduce expenses. So in energy wise, we want to reduce our waste. Okay, we do want to spend unnecessary energy. So we have to minimize the energy being wasted. So how do we do that? Again, we have to go back to the to your log, okay, to the actual log. But this time, in order for us to know where how much energy is being wasted, okay, we normally make a simulation model, okay. That's why nowadays you find that a lot of green buildings they go for energy simulation. So when you go for energy simulation, you will know the lowest possible energy that you can consume for that building. Theoretically, okay, I would say theoretically, but with this simulation model is good because you know how much lower you can go. Okay, it's just like going for limbo rock, no? How low you can go. The lower you can go, the more hips you have to bend. It's the same with energy. Okay, the energy model, the energy simulation model will give you basically the lowest energy possible for the building, and the uh, actual method, actual log value will tell you the wastages. So in a way it is so all this have to be done. Okay, compare against the simulation model. Okay, and then from the comparison, then we know okay there is a gap between the actual and the ideal. Okay, the energy simulation model is the ideal. There's a gap between the actual and ideal. So what are we going to do? So we have to come up with a list of energy conservation measures, like probably like switching off the normal lighting. Okay, probably like delaying the switching on of your air conditioning system, or maybe early switch off of the air conditioning system. Okay, so we will actually or rather the building owner will actually have to look into this to reduce the waste, and this is actually very simple to do because it's actually very low hanging. These are low hanging fruits which you can do it once a building operate. So let's look at it. Okay, so once we for this building, okay, once we did the ECM, we found that the load actually decreased. Okay, this is a regression line. This is a regression line, and this is the time we did the ECM, the first ECM. We introduced the first ECM, and these are the event that we introduced the rest of the ECMs. Okay, we didn't introduce all. We introduced only the one that's possible to be introduced. Some of the ECMs were thrown out by the management, saying that it can't be done. Okay, so but then one thing that really attract the building owners is the reduction in the TMB bills. This in RM. Yeah, this in RM. So if you look at this log from December 2015 all the way to April 2017, okay, these 2 months are actually the renovation month for the shopping mall. Okay, well, sorry, I didn't tell you what this is actually a shopping mall. Okay, so this is the renovation of shopping mall. So you will have quite a high TMB bills, and the store optimization was being done until sometime in June 2016. Yeah, so store optimization is where the store they will shift around, they will try to adjust their display, you know, to fit in, to make sure that their patrons or people that they're visiting the store are actually comfortable with it. So it took them about half a year to get it right. And after they get their setting right, then this is where our baseline observation is. So this curve here, okay, this actual consumption here is during the baseline observation. So we took about 3 months to come up with the curve, but of course we took only snippets of the particular consumption, particular day. And this is when ECM1 is being introduced, and ECM2, and all the way to ECM13. You find that the TMB bills actually drop. They actually drop after we introduce the ECMs. So this is actually a very positive sign. Here, a very positive sign. So we did again another comparison. This is the original one that you saw. Okay, this original one you saw. And then after the ECMs, we managed to bring this nearer to the ideal, and we managed to drop some of this, okay, close to the ideal curve. Okay, but we cannot do anything to the base load. Yeah, we can't do anything to the base load because the building operator, the mall operator, they wanted to switch on all their lights. Yeah, switch on all their lights. They said it's for security reason, and some of them even switch on the air conditioning for the area. So it's very difficult to drop the base load, but we feel that it is doable. Yeah, if we have probably another client, probably it is doable to drop the base load at night. Okay, so all these to help you to reduce energy being wasted. But how do you know? Is it the only way for you to reduce energy? Okay, but energy always comes out in terms of heat, right? If you see heat, that's where energy is. Okay, most of the time. So example, like let's say that if you go nowadays, right, if you go to an airport or you go to probably some shopping mall, they have this thermal scanner. The thermal scanner can detect heat. So once it heated up, then you are actually giving more energy because you are sick. That's why your body is giving up more energy. Okay, we can use this technology to detect where energy is being wasted. Okay, where energy is unnecessary being conveyed into the building. For example, okay, like building like the window mullions. Okay, we can see that over here. Okay, over here it's very hot. So the heat is actually coming in from here. So insulation for the mullion is actually very important. But I think most of the time the mullion is actually left uninsulated. So the heat actually comes in from there. Okay, another area which you can find, okay, is the bad facade insulation. You know, in most green building projects now we calculate OTTV, right? You calculate the U value. Okay, you may have a very good U value, but sometimes the contractor didn't put particular material inside. So it's reflected out compared against the other area. You see over here are cooler. Okay, by the way, the brighter the color, okay, the hotter it is. Okay, so one is hot, meaning that a lot of a lot of sunlight, a lot of energy, a lot of heat is going into the building. So over here is cooler. Okay, over here is hotter. So there's a compromise in the material here. Okay, so all this observation is very important. So insulation is actually very, very important. Okay, the roof. Okay, you find the roof. Okay, roof is actually reverse. Okay, you got wet spots. So wet spots meaning that they are actually leakages. Okay, there are leakages along the roof. Okay, so when there are leakages, when there's imperfection, heat will go in also. So all these are the area, okay, where the roof U value is being compromised. Okay, and also in the air conditioning system, okay, if you look at it properly, you will have a strip, okay, strip of very, very cold area compared to a warmer area. So in the ASU, okay, this is different. Okay, the cold air, the heat is being, okay, the heat is being okay, being transmitted into the into the panel. But for this case, okay, the cold area here means that some of the coolness is actually escaping. Okay, meaning that we can't have enough insulation to prevent the cold air from escaping. So this will also reduce sorry, this will increase the energy consumption. Okay. Same thing with outdoor ASU. You find that certain area are hotter than the rest. Okay, the ideal case is to have everything the same color. Okay, almost the same color. So once you have everything almost the same color, then we know that there's no air, there's no heat escaping or no heat going in. Okay, same. Okay, let's say for the aircon equipment, yeah, some of these are actually too cold. So until we condensate, means too cold, meaning that some of the coolness is actually escaping out. Okay, the insulation is not properly done. So the insulation has to be improved. Once the insulation improves, then the efficiency of the chiller will improve. Okay, same thing here. This is the same situation as the previous one. Okay, you have some very, very cool spots here, which actually affect the efficiency of the chiller. So if this is being repaired, then you find that the efficiency of the chiller will increase again. Same thing with the heat exchanger. And okay, for air, right, for air diffuser, right, it's very important to have a good balance. Okay, good balance meaning that you will find that the air coming out here is almost of the same temperature. Okay, so when you have a good balance, then you do not unnecessarily need to pump in more air for other side of the diffuser, for other diffuser. So when it's good balance, you find that the amount of air being drawn by the ASU will be lesser. Okay, and this will of course reduce the energy consumption too. And insulation, okay, insulation again, okay, all this insulation, okay, have to be repaired. Okay, same again, all this insulation. Okay, I'm actually in the last few slides. Then all these things you can actually easily detected by a IR camera, a thermal imager camera. And once you've detected all this, you can actually do a repair, and you find that your energy would actually reduce bit by bit. So these are the few ECFs that you can go to. Okay, and all the way until the cooling tower. Okay, make sure that everything is balanced. Okay, the heat here, okay, everything is almost the same color. You do have some area that you have more water flowing down compared to the rest, and this will actually affect the efficiency of your tower. Make sure everything is performing to the correct specifications. And another very important one, okay, this would be my last slide. And then what the important one is expansion tank. Make sure the expansion tank is insulated. Yeah, if not insulated, then you find that heat will go in and will warm up your chill water supply. Okay, so with this, I would like to end my presentation. So actually, it's very important for you to remember the 4 lessons. First, get your baseline. Okay, measure whatever measure whatever baseline you have. That's very important. Okay. The second one is to make your money grow. Go invest in renewables. Renewables is a good way for you to save your energy. Okay, and then thirdly, invest in the most efficient equipment that you can afford. And finally, reduce your waste. Okay, reduce your waste. You can actually walk around your facility. You can actually try to identify, invest in a IR camera. IR camera will tell you where the heat is coming from, and heat is most of the time is a place where you lose your energy. Okay, so with this, I would like to hand back the session to Alice. So
Thank
Alice, are
you.
you there?
Yes, thank you, Jack. Wonderful presentation, and I'm pretty impressed by the last few slides that you show. I think this is a really it's eye-opening to many of the audience around here. I mean, even though we are in the professional, each of us is skillful and specialized in most other things. But like I totally agree with what you say that the many still think that the energy efficiency may cost you a lot of money in upfront, before the potential saving that you can see that actually you can save down the road. So these are the things that there are things that we need really to do. Many talk has been given, educations through here. But what other things that you think we can do more to create or broaden or widen this kind of awareness to everyone? Everyone means either they are from this industry or other industry, so that everybody talk the same thing. Because when I look at the energy saving, it's not just in the big projects or commercial project like what we handle normally. Even though for the domestic part as well, means your households and all these things. So you might have some ideas that what can other things that we can do more.
Actually, the easiest and the most practical thing that we can do is go for low hanging fruits. Those are the things that you observe in your daily life. It actually also it also affect your habit. Okay, like for example, sometimes I go out of the room, I don't switch off the lamp. Yeah, so make it a habit to switch off the lamp when you go off. So another example, like when I plug in my PC, during the night time, I will just leave it there. Even though I have nothing on my PC, I will just close all the windows and I will just leave it there on standby. And standby actually consumes energy. So you can actually switch off the standby, and all these are very, very easy things to do. But then it's the habitual, our personal habit that hinder us from doing it. So there are many more examples. Like for example, when you unplug your TV, when you switch off a TV, do not leave it on standby. Just switch it off completely. And these are some of the things. And even for equipment like fridge, put it into a place where there is ventilation for your fridge to to reject heat at the back. There's some instances that the fridge is actually being fully enclosed, and all these things you can easily identify. But the easiest way for you to identify is that like what I said just now, you get an IR camera and you can see the heat. Once you see the heat, once you see something is heating up, then you go there and you try to do something to it. I personally, I would think that that's the easiest. This is the cheapest and easiest and very practical thing for a lot of people to do.
Yeah, I agree with you, Jack. I think the individual from our start from all of us, the lifestyle that we live on, and we take it for granted sometimes, and it's time actually for us to change also. So, Jack, I have one question from one of the participants. Oh, by the way, all the participants, you can actually have any questions, you can write, type in the chat box at the right side of the screen, and we will bring the questions to Jack, and Jack will try his best to answer. So one of the questions from one of the audience are saying that she's query that I think one of the slide was there's a pie chart and stated the word of tenant. So she's trying to think that what does this mean,
Okay, when we actually all the pie charts that you saw just now are actually actual lock pie charts, meaning that we actually do go to a building and we lock it. So when we put there as tenant, meaning that it's the power and lighting energy of the tenant. It was not possible for us at the time to separate the power and the lighting, so we lump it all in one sectors as a tenant consumption. So the tenant consumption which you saw in the pie chart is actually consists of both power and small lighting for the particular tenant.
Okay, great. So Jack, I have a lot of questions because I always like to listen to what you said because it's very informative. I think it's truly a good sharings because you see, me and Jack has been a long time we didn't see because of this pandemics. So everybody's busy when you just release out from house with your work and so this is the best chance I have to grab him and ask you and also ask on behalf of everyone's right. So okay, Jack, we know normally when it comes to the energy management, right? There's always a cycle or a set of a standard sequence that everyone will say that you plan, then you do, then you check, then if any problems or anything, you take action. So, but how well or how popular I put is this way? This kind of a standard sequence or cycle is being adapted or implemented in at least all the buildings in Malaysia.
Well, many building managers, they wanted to adopt this. This is also being recommended in the ISO 50000. So it's one of the recommendation to be do, but it's not easy to follow and thoroughly. So most of the time, you would need a lot of energy, a lot of commitment to follow through. So what we do find out is that the intention of every building managers are true. Even building owners, they want to reduce energy. They want to reduce energy, but they do not have the seminar to follow through the whole steps. Probably after one or two steps of the plan and check, they decided to leave it. Okay, very few will just go until the end and then come back again, to reassess the energy again. So this is probably one of the drawbacks of our industry. Then so it's actually quite tough. So far in my experience, most of the time when the building go for green certification, okay, they will try to meet the energy index, okay, especially the BEI, and after meeting it, then they will leave it for 3 years, do nothing, and then when the time for recertification, they will get back people like us again, and then they will try to recertify the whole building. But it's actually quite tough because once you leave it without the management part, without the energy management part, then it's very difficult to pick up again. So this is a gap. This is an industry gap in our nation. Okay, we have the standard, we have the criteria, we have the benchmark, but we do not have the maintenance culture. We do not have the management culture to maintain the energy system. So probably as an industry wide, we have to sit down and we have to think of a way. Probably we need to engage the government sector to sit with us and provide some incentive to building owners to go through with the program.
Yeah, I agree. But when they wait for another 3 years, when the moment that you want to renew the certification, isn't it a bit too late? And then the cost incurred could be much greater than you constantly maintain it. Don't you think so?
Yeah, definitely. Because if you maintain a system, right, you will actually have the confidence. Okay, you will have the real data, the confidence that you are actually saving energy. And once if your data is out, say that if your index or if you find that it's at any point of time that you're actually not getting the energy safe, you are not getting, you're actually wasting more energy than is required, then you can have some ECMs, you can do an investigation at that particular point of time, and not wait until 3 years later then you find out, then you have probably have wasted about 3 years or maybe 2.5 years of opportunity to save the energy.
And the money also, right? I think they buy.
Yes.
Yes, if all of us like mislook or mismonitor these kind of things, then the money and dollar cent just fly over like that,
Yep.
Yeah.
Yep.
Yeah. So but good thing is I also see some of the started to have some of the building owners, they really maintain because they really mean serious. But I do agree that we need more. We need more this kind of attitude, because build a very nice aesthetic building is definitely great, like getting a new house, car, new whatever. But the maintenance, yes, totally agree. So Jack, come to this. There are people a lot saying that about monitoring based commission, or in the short form called MBCX, right? So could you maybe elaborate a little bit that um, because it's been widely used in a lot of these kind of so-called developed country, that really emphasize into energy efficiency. So maybe you can elaborate a little bit. Maybe I don't know. Maybe Malaysia is not really popular by using that yet. So maybe this is the time. Maybe you can share, how effective it is, by applying this.
Okay. Personally, I have not used any MPC, but it's being quite. I mean, it's being used in probably in the US, or probably in some European countries, and it's also one of the requirement is for enhanced commissioning for lead projects. So lead is actually looking into implementing MPCX into their certification. So one thing about MPCX is that it's actually continuously monitoring system, mean that you have to use your BMS or any monitoring system and put some set points, and put some algorithm into the equipment itself. Okay, let's say example, like maybe you have a fridge, okay, and then you always take the current of the fridge, the power of the fridge. So at any one time, that probably, if let's say the power of the fridge actually exceeds certain design limit, an alarm will be sent off, or maybe if it can correct itself, the algorithm will correct itself. So this is what, in very simple gist, what MPCX is, meaning that we are using the technology that we have, especially IT technology, and we are and put an algorithm inside, okay, or put a monitoring program inside, and if any of the devices actually operates out of the norm, a self-correcting algorithm will be implemented if possible. If not, then an alarm will be sent to probably the technician or the maintenance guy, and he will actually look at it. So this is in a simple terms of what MBCX is, but it's still quite difficult for us to implement, because it incorporates many different platforms. Like you will incorporate the BMS people, you incorporate the equipment supplier, you incorporate the building owners, and all these people have to talk first. Then only we can get quite a decent system out.
Yeah, there's always a start, right? Yeah. Well,
Yep.
of course, when you start, a lot of people, or material supplying or manufacturers say, "Oh, we really hope that the profession like us, architects, engineers, people like Jax to be more actively, and how to collaborate with the policymakers and all these things, to make sure these things is work and it carry on. So well, we are still doing that. Okay, Jack, there's one more thing that I think is always a confusion. It's always a question, and popular question, or some maybe they just keep it, they thought that they know, but actually may not. They I believe that many still cannot really differentiate what is the differences between the renewable energy and the energy efficiency in the technologies. Maybe you can. Yes.
Okay. Renewable is actually like energy that we get in a way, like in a very layman term, like we can get it free. Okay, like example, like a solar, wind, okay, water current. Those are the things that those are the things that we can actually like tap. It's given to us naturally. Okay, God given stuff. Okay, it's something like God given stuff, naturally occurring. Then we just reuse it. Okay, we reuse it, but we actually like in a way, we renew the energy from being like sunlight. We actually convert it into electricity. Okay, so it's something naturally occurring. So energy efficiency is something that's already in the equipment itself. Okay, probably you're consuming already. Okay, it's something like air conditioning. It's already in the equipment. So if you make it more efficient, meaning that you have to do some changes into the equipment itself. Okay, you have to change certain part of the equipment, and you replace the part with a newer part or with a more technologically advanced part that actually consume less energy. So there's more on efficiency. So the more you replace the parts, the more efficient you get. Okay, maybe for example, let's say you, okay, let's say what good example can we have? Okay, let's say example. Okay, maybe you have a car. Okay, then you have a very old car, so maybe you consuming a lot of petrol. Then you decided to change the carburetor. Okay, so you will actually consume less energy. Then over time, you decided to change certain valves. Then you consume less energy again, but it's still the same car. It's still the same car, but you're changing a lot of parts. So you're making it more efficient. So this in a gist is efficiency. So you're making the thing the same thing, but performing at a better performance compared to before. Renewable is not there. The thing is not there. You create something from naturally occurring substances like sunlight or wind or current or whatever, maybe even biomass. So you're creating something, in other words, creating something out of nothing.
Yeah, I agree with you because I also kind of emphasize that a lot of natural free resources around us. We just have to be very creative and know how to use it efficiently. That is one of the major key factors that can help you to reduce a lot of costs, right? If you know how. The one I saw you just the harvest things, the propeller in the river and to generate something. I think that's pretty interesting. I'm gonna learn that from you. Okay.
You can use
One
it for
question.
camping.
Yeah. I never thought of that, So that is the beauty that I like to talk to you. I did have so much information this morning. So Jack, one last question, and
Okay.
well, it's also a very popular question. I think this is among always we have this kind. I call it arm wrestling, but it's a friendly types. That when you talk about energy efficiencies, it's always versus again the aesthetics. So it's between the architects and the engineers. So one time the engineer want to give all these kind of things to make sure everything performs up to the most efficient way. But with this kind of equipment, they come to certain sizes, and then like I said, wow, I want to do something, to make it. Yeah, I heard some say I want to make it disappear. Oh, so that sounds a bit ridiculous. It can't be. So that is always a challenge. So in your situation, I'm sure you encountered to that. So how are you going to convince the architect?
It's always go to communication. it's a it's a it's a very difficult question to answer, because
Mm,
both architects and engineers, right, looking at the same particular product but at different angles. So it's very difficult. Let's say that if one insists on his angle, then it will be skewed to one side, and if the other insists on his angle again, it will be skewed to the other side. So it's always a balance. It's always communication balance, and what is the expected result. So it's not an easy thing to do. Then besides architect, then we have to talk about the cost. The owner will get involved, the estimators will get involved, and then sometimes even the civil engineer will get involved. It's not even electrical, mechanical. Civil engineer say, hey, I can't have this thing down here. So it's it's a big communication a big communication setup lah. But I'm glad that recently, right, all this is being trashed out, especially like in forums, like as example like GBI, like in forums, like in green forums. There are all these quite professionals from different areas. Okay, they come together, and everyone is given equal opportunity to share their ideas. So eventually, you would need someone that actually can incorporate all the ideas together and come to a solution, which actually is not that easy. Is actually when you deal with professionals, every professional will have their own pride. You say that, okay, I want my building to look like this. Then the engineer said, no, I want the equipment to be performing like this. So you can't have this because there's no place for me to put my equipment. So a compromise is actually very important. So communication among the professionals are very, very important. And like what I said, I'm glad that we have platform for this. Even in PAM is actually putting out a platform, not only including the fellow architects, but also including other professions. So as more professions come in, then we can share more ideas. And with more ideas, then we can make better decisions.
Exactly. I totally agree with you. The key word is communication. I actually, seriously, to share my experience, I have so much communication with all different, all others engineers, either in the civil structures, mechanicals, or electrical. Learning is no boundary. I think not just apply to the architect, but to all the professionals. So we need to understand each other things, and I found it that many people have the thought is a challenge is because that everybody have a shield to protect their self. So yes, you have your everyone have their own skills and professionals, but let's talk it out. So the communication, the more you talk, I think the barriers will be gone, and you will come up with much more better buildings in terms of aesthetically as well as functionality, right, Jack? So,
That's
okay,
right.
I said this is the last question. So, because this is time allowed for this session. Of course, I have other things for Jack. I know in this pandemic, people talk about the performance of this, the high performance or HENC. I'll do some sketch. Later I share with you, and you advise me privately behind. All right, thank you, everyone. I think thank you so
Yeah,
much,
thank
Jack.
you, thank you so much. Thank you so much for your time.
Yes, it's our really a pleasure to really get Jack to be with us this morning. And okay, to all the participants again, I thank you so much for you to spend your time together with us this morning. And last but not least, gentle reminder to all of you, the things that I mentioned just now in earlier, two things that you can claim your CPD points by this now. The code you can see is running through again. Code you can claim from that, and again, do not forget the small little short survey. It will just maybe spend your 1 minute or 2 minutes to just fill it up. This is very important to us to help us to know that what you think, what you thought. We from there we improve from ourselves. Of course, for those audience or participants, you have questions, you can put it in there so that we'll try our best to see how we can respond to you to the e-platforms. So thank you so much to Jack, to everyone, and stay safe, keep yourself safe, and have a great year end of 2020. I'll see you soon. Bye. Jack, say bye to
Thank
all.
you. Bye bye. Thank you. Thank you so much.